Hello friends, I'd like to show you a shape that has some really interesting properties. We can create this special shape by starting with an equilateral triangle, removing the inner third of each side, and then placing another equilateral triangle in the place where the side was removed. If we repeat this process infinitely, we end up with a shape known as a Koch snowflake. And this snowflake is fascinating because although it has a fixed area, it has an infinite perimeter. So how can a shape like this mathematically exist? Well, as the number of generations increases, the area does increase, but less and less each time. At first, the area increases by 1/3 of the original, then 4/27ths, then 16 243rds, then 64 2187ths. You can see how the amount of area added with each successive generation is very quickly trending towards zero. In mathematics, this type of sequence creates what is known as a limit. And what it means in this case is that, although it may intuitively seem like the shape's area will grow infinitely, it actually doesn't. There's a limit to the growth. This chart shows how the shape will never grow beyond 1.6 times its original size when it was just a triangle. And because the shape is limited to this 1.6 value, we can say with certainty that the shape has a fixed and not infinite area. Simply by being able to see this two-dimensional shape in its entirety, we can prove that the area is finite. If the area were infinite, there would be no boundaries to see. And with no boundaries, you really haven't got a two-dimensional shape at all, only a blank infinite plane. The perimeter is a different story. As the number of generations increases, the perimeter of the snowflake continues to grow and grow without approaching a limit. The math works like this. Each generation of the snowflake has a perimeter exactly 4/3 of the previous generation. If you zoom in and look at just one side of the triangle, it becomes easier to understand. With each generation, the perimeter that is added is 4 times 1/3 of the original length, giving a total growth with each generation of 4/3, or 1.3 recurring. Because this number is greater than 1, the perimeter will continue to increase, trending towards infinity. This is the most non-intuitive aspect of the shape, because it seems as if the perimeter could be measured, but it cannot. Because no matter how far we zoom in on the shape, there would always be more perimeter to measure. And that's how you can mathematically have a shape with a fixed area, but an infinite perimeter. Hopefully you've learned something today, or simply found this video interesting. Either way, if you'd like to see more videos like this, make sure to subscribe to my channel. And if you've not already done so, don't forget to hit the bell next to the subscribe button so that you can have the best chance of actually seeing my videos on YouTube. Anyhow, continue learning. My name is Randy Dobson, and I'll see you next time.